Okay, so this is our weak acid strong base part 3 video. Now this point, we're going to reach the equivalence point in this one. And we're going to explain what that means when we reach it. Basically, we've still got our 50 mils of 0.10, so that's 0.010 moles of acid. And we end up having 25 mils of 4 molar. And that tells us we have 0.10 moles of NaOH. This is going to be our initial. And what would happen at our final is all of our HFO, all of our NaOH reacted, and what we end up with is 0.010 moles of NaFO, and of course some water that we don't care about. So what we have to do at this point is flip the reaction. Now I said we would get to that equivalence point, and here we are. What we have is equimolar, equal moles, equimolar amounts. What that means is the moles of HA are equal to the moles of OH minus. So now the only thing left that's controlling the equilibrium is our FO minus. And so we're going to flip this reaction and let the FO minus control the equilibrium by reacting it with a little bit of water. That's going to give us a little bit of HFO and also a little bit of OH minus. 0.10 moles. Now that was 0.10 moles. I've got to get that into a molarity. My apologies. I've got 0.10 moles divided by 0.075 liters. So I have 0.133 molar of FO minus. And now this is just going to turn into a nice weak base problem where we have nothing, minus x, 0.133 minus x, plus x, plus x, plus x, plus x. So what we end up with is x squared over 0.133 equals KB. Now be careful here because we've got to calculate the KB. So the KB is going to be KW, 1 times 10 to the negative 14th, divided by 1.8 times 10 to the negative 4th. That was all given in this problem. And if I look at that, that gives me a KB of 5.6 times 10 to the negative 11th. And so now I can say, and yes, you guys are going to correct me and say, assume x, as x neg. And now let's say x squared 0.133 equals 5.6 times 10 to the negative 10th. X equals concentration of OH minus, and that's going to be 2.73 times 10 to the negative 6th. I'm going to check that assumption. 2.73 times 10 to the negative 6th over the original, which was 0.133, of course, times 100. That's going to be way less than 5%. So we're okay. Our assumption's valid. So the POH equals negative log 273 times 10 to the negative 6th, which in this case is 5.56. So my pH equals 14 minus 556. So we have a mildly basic solution at the equivalence point, which we would expect because we have a weak acid and a strong base, and the base is going to take over a little more of this.